Hey guys, today we are going to learn about forward propagation in the neural networks and also backward propagation in this neural networks concept. And let's build one single layer neural network. This is the input layer, this is the hidden layer, and this is the output layer, and we can get output here. The predicted value is y hat, right? Here we will get features as inputs, and we had weights w1, w2 and w3, right? And in this hidden layer we all know there are two steps, right? One is weighted sum of the inputs plus bias, and the second step is activation function like tan h, sigmoid, relu, right? When we got the input, we will calculate the weighted sum and we add bias for this, and after that we will apply activation function on that, right? And here we get the predicted value y hat, and we don't know whether it is correct or not, so we need to find out the loss function. The loss function is equal to the truth value minus y predicted, right? And we can see for back propagation for the same neural network, here back propagation for the same neural network, and you can see here, you consider this graph, and here we had global minima, we got the loss value, and we need to decrease the loss function to get the global minima value, right? So for that we need to update each and every weight for that, and these weights were updated by the optimizers, and there are several types of optimizers like gradient descent, Adam, SGD, and many more. So in this back propagation, after calculating the loss function, we need to update the weights. So after updating the weights, and again it goes to the forward propagation, and it goes on until we find global minima value, right? And we had weight updation formula, that is weight of nu equal to w old minus learning rate into derivative of loss with respect to derivative of current weight. This is the weight updation formula, weight updation formula, okay? And this is the learning rate, and I will explain you what is learning rate. Consider this graph, and we are at here, and the global minima is at here. The learning rate means like how fast, like how many steps we need to take. If the learning rate is too low, consider it will take so many steps, right, to find global minima. If learning rate is too high, then it will cross the global minima. So the learning rate plays major role, and this is all about the forward propagation and backward propagation. Let's quickly recall the session. For forward propagation, input comes, and we had weighted summation of the weighted inputs plus bias applied on the activation function is applied on this, and then we will get output, right? In between we had weights. For backward propagation, the output means y hat, right? The loss function equal to y minus y hat. And after that, optimizers will update the weights, right? Using weight updation formula. Weight updation formula. And then after weights were updated, and then it goes again here. And if the loss function, we didn't find any global minima, right? If the difference between the truth value and the predicted value is high, then it goes again here, and the optimizer update the weights using the weight updation formula and goes here. And we know there are so many types of optimizers, like gradient descent, stochastic, gradient descent, mini batch, SGD with momentum, and Adam, which is very famous. And we had so many optimizers which updates the weights using weight updation formula. And I will make separate video on the optimizers, and this is a short video. Hope you like it. Thank you.